Hi there, and welcome to another Pencast for the course Reasoning and Logic. In this one, we again treat an old exam question, which is about equivalence of propositions in propositional logic. So we have two propositions, and one of them seems to contain a letter that the other does not. And answer D is about this very case. It says that the two statements cannot be equivalent because the second one contains an R, whereas the first one does not contain an R. But let's think about that for a second. Consider P and not P, and P and not P, and R and A and B and C, and well, might as well throw in a variable called Cinderella, it doesn't really matter. These two things are equivalent. They're both a contradiction. Now, this is just here to show you that two propositions can be equivalent even when they contain different letters. This is not only true for contradictions, nor is it only true for tautologies. Even for contingencies, we can easily create situations where two propositions are equivalent even though they contain different letters. So answer D is false. This is not a reason where they can be equivalent even though the second one contains an R and the first one does not. Now, let's see what happens then. So, to test whether they are equivalent, we need a truth table. I've explained how to create those in other two videos, so I'm not going to bother with that here. If you want, you can pause the video about 20 seconds from now, and you can check whether you understand how I created the truth table. Do note that I again indicated the main connectives here, which is the negation for the left one, and for the right one it is the implication in the middle, which I indicate as the main connective now. Okay, so currently they are not equivalent. Their truth tables are different. So we can remove answer A as a possibility. Now answer B says, how about we add not or not Q to the left one? What happens? Well, the bottom half of the truth table remains the same, which is good because they are already equal. But the top half becomes only once, and this is not what we want. So answer B is also false. So, well, we've eliminated A, B, and D, so answer C must be the right answer, but let's try it anyway. What happens if we add and P to both of them? Well, we can make the truth table, and we can see what happens, but I prefer the alternative approach of thinking about it. Because doing the truth table, well, it works, but it's a bit of work as well. What happens when we add and P to a phrase? Basically we're saying, well, it can only be true if P is true. So the top half of our truth table is going to be 0 regardless. The bottom half, however, is going to remain exactly what it used to be before. And as we can see, the bottom halves of the truth table, the cases where P equals 1, were already the same. So by restricting ourselves to just those parts of the truth table, we have indeed made the two propositions equivalent. Now hopefully that cleared up a bit how you could have found the right answer to this question. And with that, I'll see you around for the next one.